हेलो एवरीवन, कैसे हो बच्चों? दिस इज अमित वर्मा, पीजीटी केमिस्ट्री, गुडा इंटरनेशनल स्कूल, गुडागोरजी. Today we shall talk about the chapter solution from the beginning. So here it goes. So the first thing, what is a solution? Solution is termed as the homogeneous mixture of solute and solvent. Now here I have used very significant term. Kindly notice this. Homogeneous. Homogeneous means to say equal distribution. So the mixture of solute and the solvent, in which the distribution of solute in the solvent is same, or you can say that it is equal. I am giving you two examples. There are two beaker A and the beaker B. In beaker A, we mix some sand in water, while in the beaker B, we mix table salt in water. By our daily life experience, we can easily tell that the distribution of sand in the water is not equal. When you mix sand in the water, usually the sand particles, as they are very heavy in the size, they will settle down in the bottom. As the sand particles are heavier and larger than the molecules of the water, that's why these molecules will settle down in the bottom. So the concentration of sand here in the bottom is more, while the concentration of sand in the above surface of the water is very less. So here the sand is not equally distributed. So it is not a solution. When we mix salt in the water, the salt concentration on the surface of the water, in the middle of the water, and in the bottom of the water is same. So we will say that the salt and the water mixture is homogeneous in the nature. So it is a true solution. And in this chapter, we are going to talk about these solutions only. Now we are going to classify the solution according to various bases. So the first basis is on the basis of solute solvent phase. Instead of this phase, I can give another name also, state. This word is very familiar to all of us. Liquid, solid, gas. Now see carefully. I'm going to make a table right now here. Let's see. Solute, solvent. If solute is liquid, solid, or gas, or solvent is gas, gas, and gas. Similarly, if solute is liquid, solid, gas, while the solvent is liquid, liquid, liquid. And the third, if solute is liquid, solid, gas, but the solvent is solid, solid, and solid. Before processing this topic further, let me clear you one thing. The component which is present in the less amount is termed as solute, while the component of the solution which is present in the large amount is known as solvent. So, what if liquid is present in the gas? For example, examples of such type of solution is liquid in the gas, liquid, water droplets, tiny water droplets present in the air in the form of humidity. Or you can say the clouds. The clouds are actually the solution in which the solute particles, the tiny water particle droplets are present in the air, which is a gas. Now the next example, solid in the gas. Solid. See the dust particles, they are suspending in the air. So, dust particles in air. Gas in the gas. Oxygen, which is 21%, present in nitrogen gas, which is more than 78%. So here N2 is a solvent and O2 is a solute. So actually it is what? It is, these are the components of air. So air is the solution in which the solute is also gas and the solvent is also a gas. Move to the second category, liquid in the liquid. Ethanol. Ethanol is liquid, important component of liquor in water. So see, ethanol is liquid, water is also liquid. As ethanol is in the small quantity, it is termed as solute. Water, if it is present in more quantity, it is known as solvent. Solid in liquid. Very familiar example, sugar or salt in the water. Gas in the liquid. We all have drink soft drinks. Soft drinks are usually made by the carbon dioxide, which is a gas, in the water. So, example is soft drinks. In the soft drinks, carbon dioxide gas is dissolved in the water at high pressure. Liquid in the solid. Liquid, which is mercury. Mercury is liquid. You all know that mercury is only the element which exists in the liquid state at the normal temperature. Mercury, which is in the liquid state, in sodium, also known as sodium amalgam. Solid in solid. Copper in gold. Or you can say them, these are the alloys. Alloys are the combination of two or more metals, homogeneous mixture of two or more metal is known as alloy. Various type of alloy, here you can give any type of example of any metal in another metal. Gas in the solid, very important kids. In the last year in class 11th you have studied about it, that the gas hydrogen is adsorbed by, I'm not spoken the absorbed, I have spoken adsorbed, NAD adsorbed in the solid, which is palladium, hydrogen gas in palladium, interstitial hydrides, right kids? So this is the classification on the basis of solute solvent phase. Kindly have a screenshot of this and kindly write it in your notebook. The next classification is on the basis of the concentration, on the basis of concentration, on the basis of concentration of solution. The concentration means to say amount of solute present in the solvent. So here it is classified into three categories: saturated solution, unsaturated solution, and super saturated solution. Let's see, kids, what are the saturated solution? These are the solutions in which maximum amount of solute is dissolved and there is no possibility to add more solute. So simply we can say that in these solution no more solute can be added. No more solute can be added. Unsaturated solution, in which there is a possibility to add more solute. More solute can be added. And supersaturated solution, these are the solution in which the amount of solute is more than its solubility. Very important point, kids. The amount of solute is more than its solubility, means to say more quantity of solute is present than its solubility. So now the question raises, where does this more solute will exist? Actually, this more solute, more than solubility, the more solute will be present in the bottom of the beaker. Such type of solution is known as supersaturated solution. Now the classification is over, kids. Now we shall talk about the next topic, concentration of solution. Concentration of solution. Now, what do you mean by the term concentration? Concentration means to say the amount, the quantity of solute present in the unit volume or mass of solvent or solution is known as concentration. So the concentration is always given on the basis of solute, not on the basis of solvent. So simply I will describe it. The concentration is the quantity of solute. The quantity of solute. The quantity can be measured in mass or in the volume, both. Present in the quantity of solution or solvent. Either solution and solvent quantity can also be in the mass or in the volume. Right? So you can say that concentration is the ratio of solute with solution or solvent. The concentration of any solution determine its various properties known as colligative properties, which is very important part of this chapter that we will study after some certain topics. Till that, we will cover very important topic from which many questions in the competitive examinations are being asked. So the topic is unit of concentration. Unit of concentration. See kids, first unit is mass by mass percentage. Kids, have you noticed this thing? When I have spoken mass, I have written W. So the symbol of the mass is W. The second one is mass by volume percentage. The third is volume by volume percentage. The fourth is molarity. The fifth is molality. The sixth is ppm. 7 ppb. 8th normality. And also very major unit of concentration is known as strength. Now we are going to study about these units in detail. So first, start with the mass by mass percentage. Let's see kids. Mass by mass percentage equals to mass of solute. For the solute we will use 2, for the solvent we will use 1. Let's see. Mass percentage equals to mass of solute upon mass of solution multiply by 100. Kindly note down that in the below side I have written the solution, and solution is actually having two components, solute plus solvent. Kindly note this thing. Symbolically we can write it, the mass of solute, as we know the mass is represented by W, and for the solute we use 2, and for the solvent we use 1. So here what is that? Mass of solute. For the solute we will use 2 W2 upon mass of solution. So mass, it's W. For the solution we will use no term, not 1, not 2. It's just W. So W indicates the mass of solution multiply by 100, because percentage is always given on the basis of 100. Now second, W by V percent. W by V percent is equals to, W means to say mass. Mass of solute upon volume. V means volume. Volume of solution multiply by 100. Symbolically we can write W2 upon V multiply by 100. Now we will study about our third unit, that is V by V percent. The third unit is V by V percent. So V by V percent is, actually I have used here V. V means to say volume. So I can write here volume of solute upon volume of solution multiply by 100. Symbolically we can write that volume of solute upon volume of solution multiply by 100. Now we will study about the fourth unit, mole fraction. See kids, very important word, fraction. Fraction means to say parts. What parts? The parts of the mole. So assume that in any mixture or in any solution we have two components, component 1 and component 2. Solute plus solvent become solution. Now in this case, if one component is 1 and the another one is 2, then mole fraction of component 1 equals to moles of 1 present in the solution upon total moles of solution. I can write here like that the mole fraction of the component x1. So here x is representing the mole fraction. The component 1 is termed like this, that the x1 mole fraction of component 1 equals to the mole of 1. Mole is represented by n upon total moles in the solution. As you know that in the solution there are two components, 1 and 2. So here I will write here that the mole of 1 plus mole of 2. Similarly, the mole fraction of 2 equals to the mole of 2 upon mole of 1 plus mole of 2.